are you? Okay. Today, we're going to talk about area of surface of revolution. Recall that in 6.2, we talked about values of solids of revolution. And today, we're going to talk about area of surface of revolution. A surface of revolution is formed when a curve is rotated about a line. So this is the y-axis, and then we have this nice segment over here, and the length of this is h. So now I'm going to rotate this nice segment about this y-axis, and I'm going to get a surface. So I'm going to draw a symmetric image on the other side. I'm going to get a surface like this. Now the question over here is, so what will be the surface area? Well, given that the radius over here it is r. So what's the surface area? So what will be the surface area over here? Well, if you cut along over here and open it up, then this is going to be like that. Okay, and it's just a rectangle. Right? The width over here is h. What's the length of this rectangle?
2r.
2 pi r. Okay. So we're talking about area. Okay. So yes, someone answered it in the chat. So this is going to be 2 pi r. Okay. The circumference of this circle over here, it is 2 pi r. Right? Okay. So the area will be 2 pi r times h. So that's the area for that. Now this is when you have a surface of revolution like this, then this is the surface area. This is called surface of revolution. So you revolve this about this y-axis. So one example of a surface of revolution. Now over here, again, this is the y-axis. And this time we're going to have this, say we have this nice segment over here. The length of that is L, okay? And we're going to revolve this, okay? We're going to rotate this, right? About this y-axis. And then you're going to get a surface of revolution. And giving you this over here is big R. We'll use a different color. Okay? So this is the big R over here. Okay. Now, the surface of revolution will be like a cone, right? Like a ice cream cone. Okay. So what will be the surface area over here? So what do you think? So what should we do? So again, we're going to use a scissor, a pair of scissors, and then we're going to cut along the edge, okay, and open that up. So when you open that up, it's going to be like this, right? Think about it. This is L. What about this arc length over here? So what is this arc length right here? This arc length right here corresponds to the circumference of the circle over here, right? So that will be 2 pi r. Okay, so that's 2 pi r. What's the area for this? What's the area for this? Any idea?
For triangles, sometimes you use half, right? So would it be pi r l?
Yes, you got an idea. Okay,
Wouldn't you find that
okay.
percentage like that?
So this kind of remind you. Okay, so if you slice this up, right? So if I slice them into very thin slice, okay, each one of them remind you of a triangle, right? So when you slice them into small slice over here, so this art here is almost like a straight line. You can approximate that by the line segment connect this point and this point, right? So what happened over here, it is going to be, because this one here is so small, so short, right? So it's almost like so each side here, it's almost like a triangle. So it's like, if you think about that, it's a straight line right here, okay? So we know that for triangle, it is, the area it is 1/2, right? Times base times height. So 1/2 times base times height. So you use the 1/2 and then times this base times the height. The height over here, when this lies over here, it is so small. Then the height is actually, you can approximate that by this, the radius of this, the big circle. Okay, think about this as a part of big circle with radius L. So the height over here is, you can think about like L. Okay, like L over here. What's happening over here? The base is this arc over here. And when you sum up those, each small arc over here, then you get this, the whole arc over here. So now the total area for this over here is similar. You can use 1/2 base times height. So this will be 1/2. The base, when you add up those base over here, right? So it will be this r over here will be 2 pi r. So that's 2 pi times the big R. And the height over here is the L. Now the 2 and the 2 here cancel, and that will give you pi RL. That's equal pi RL. So in the future, if you have an ice cream cone and you can think about the surface area, it's actually pi times the radius over here, okay, times this, it's called the slant height right here, the L, that will give you the surface area, okay? Now, over here, you compare this one with this one. They're a little bit different. I'm trying to connect these two together. So instead of letting, using this big R over here, I'm going to use this small r over here. The small r over here, it is actually the middle. So I take the middle of, I'm taking the middle point over here from this to this, okay? The middle from this one to this one. And this small r here will be half this big R over here, okay? By geometry, if this is in the middle, then this is half of this. Then what happened over here? Then this pi RL is going to turn into, so the area for this is going to be 2 pi and then this small r right here. Now, how did you do this? Because this big R over here is equal to 2 times small r over here. So we have the same formula like this. Okay. Now with the R over here being the average or this, it being the radius of the radius of the circle right in the middle. Okay. So this is actually, you think about this circle over here, that's actually in the middle of this surface of revolution right there. Okay. Another way to think about this formula is this. Okay. I'm trying to help you to think about another way to understand this. Okay, so we have a circle over here. This is the L. So notice that this area over here is this one. So I'm just putting that in this big circle. So this is one part. This is just a part of this big circle over here with radius L. Now with this R over here to be 2 pi times big R. So if you try to find this area over here, then we can find the area for this whole circle, which is going to be pi times L squared, right? That's a whole circle. But we're not getting the whole circle. This is just part of it, right? So then we times. Now think about this part over here. It is, so we'll use a ratio. So this R over here, it is 2 pi R. The whole circle over here, the circumference over here, it is 2 pi L. So the circumference for the big circle, it is 2 pi L. Okay. And the arc length over here is 2 pi R. 2 pi times big R. So what happened over here is the area here is proportional to this arc over here, right? So if you have 2 pi L, then you get the whole circle, right? So this arc over the whole circumference will be this ratio over here. So this area over here will be the total area times this ratio over here. Okay. Now, if you simplify this, so that is going to give me pi times big R times L, which is the same formula that you have over here. So that's another way to think about it. Or you can think about that as almost like a triangle, right? Each slice is triangle and you sum up them, right? So it's 1/2 base times height. So 1/2 times this, think about it as the base, and this is the height, and then you will get this form, right? So two different ways to think about it, okay? So this is the y-axis, and then what happened here is we're going to rotate this line segment over here that has length to be L, okay? Going to rotate it about this y-axis, and then we're going to get a surface of revolution. Okay, so what will be the surface area over here? What do you think? Well, I haven't given you this, right? So this radius over here, it is, let's call that R1. This radius over here, let's call that R2.
Maybe 2 pi R2 minus R1 times L.
Okay. Kind of close. Okay, kind of close. Okay. So let's investigate this a little bit further. Okay. So again, let's use a pair of scissors. Okay, and cut it along. Okay, this, and open this up. Okay. So okay. So when you open this up, you're going to get, so this is L. Okay. And this right, this arc over here, it is, what's the length of this arc? 2 pi times R2, right? And the length for this arc over here is going to be 2 pi, would be 2 pi times R1. And now we're trying to find this area over here. Okay, so we're trying to find this area over here. Now, just like before, okay? So you can think about two different ways, okay? So think about this as a part of this big circle, right? Like that, okay? Or you can also slide them, okay? Let's slide them this way. If I slide them into thin slice, then each slice here is almost like a trapezoid, right? So we know how to find trapezoid, right? Area for trapezoid, okay? So if we have this, because the slice is so small, then it's almost like a line segment right there, right? And then we can have for trapezoid, okay. Well, my Wi-Fi is a little bit slow today, so it doesn't show right away. Let's just hold it. Okay, you see it, right? So we know that what's the area for a trapezoid? Given the base over here, so this is B1 and then B2, the top base and bottom base. And giving you the height over here is H. What's the area for a trapezoid? It is what?
B1 plus B2.
Yes. B1 plus B2, and then times the height times H, and then divide by 2, right?
2. Yes.
You got it. Okay. So in Chinese, we call that 上底加下底跟高除二. All right. So this one over here, it is going to be, now each slice over here is like almost like a trapezoid. Okay. And then when you sum up those top base and bottom base, so think of them, it's going to get this whole arc over here. Think about it like that. Okay. So if I use this formula, so I'm going to get 1/2. Okay, so then we have 1/2. The top base here, so it's going to sum up to this 2 pi R1. So let's put it down. So 2 pi R1. And then plus the bottom one over here, okay, is 2 pi R2. And the height over here, okay, when the slide is so thin, you can use this L for the height, right? So, and simplify this, you get pi times R1 plus R2, and then multiply with L. That's this area, the yellow highlighted area over here. Now, notice that it's a different formula, different format like the one we had before. Okay, let's relate this with the other two formula. So this time, instead of using R1 and R2, let's think about this circle that is actually, let's take the middle point of this. So the middle point of this is this one over here. And then we're going to draw a circle that goes through this. Think about this middle point, revolve about this y-axis, you get a circle. So we got this circle over here. So that's a circle, the middle. And the radius for this, let's call that small r. That's a small r over here. That's a small r, okay? Because this is in the middle, think about this by geometry. If this is in the middle, then how is this small r related to r1 and r2? Small r will be equal to, what do you think? How does it relate to, how does this small r relate to r1 and r2?
It's just R1 plus R2 divided by 2.
Yes, it's the average of this and this, right? This is in the middle, okay? So that is 1/2 R1 plus R2. In another word, R1 plus R2 is equal to 2 small r. So over here, we can replace it by 2r, 2 small r. So that's too dark. 2r right here, okay? Now the formula for this over here, finally, we got this area for that is going to be equal to 2 pi times small r times L. So that will be the sum formula. Okay. Okay. Now looking at this 3, okay. So it's always 2 pi RL. With this R here being taking the middle point of this nice segment right here. Okay. Revolve that about this and get a circle, and R is the radius of it. Okay, so this R here is also the radius of the circle in the middle of this, right? Okay, and then this R here is actually radius of circle in the middle also, right? Okay, so all of them is 2 pi R times L, okay? So after this, then we can try to discover this, okay? So over here we have this x-axis, and then we have this. So we have one R over here, okay? And we're going to without rotate this, okay? About this x-axis. So rotate like this. And then we get a surface of revolution, okay? The way that we draw it is we can draw a symmetric image of this on the other side of this x-axis. Let's think about this. Okay. I want like a waist over here. Okay, so we start from point A and end at point B. We try to find this area, the surface area of this. So how do we do that? So the way that we do it is this. Okay, so we're going to cut it up. Okay, in calculus, we like to slice it up into small part and then sum up the small part and use integral, right? So I'm going to slice this up, okay? And I'm going to divide from A to B into n subinterval with equal width delta x, okay? And then we get a very thin slice, okay? So one particular slice will be, let's just draw over here. Okay, so this is one particular slice over here. So think about this is one particular slice over here. This is maybe on the I interval. So this corresponds to this xi. This is the I stripe. Okay, so imagine your end of them. This is one band. Okay, so this is xi. Okay, now correspond to this point over here. This point over here, x coordinate is xi, y coordinate is yi. This function here, it is y equal to f of x. So yi is f of x. Now, if I can find the area for this one band over here, okay, and then later on we can sum them up, right? And use integral to find the total area. Okay, so let's focus this on this I slide here, this one band over here. So what's the area for this? So that will be, we just discovered the formula, right? So that is, well, first of all, what does it remind you? Okay, let me first, this one band over here, kind of remind you of this. Now, if the slide here, it is so thin, Then this one over here, this R over here, you can think about it's almost like a straight line, right? It's almost like a straight line right here. Okay. So that will remind you of this case, right? Of that one. Okay. And surface area over here, it is going to be 2 pi r, right? 2 pi r times L. So this is the circumference. Okay, remember what is this 2 pi r? Okay, the 2 pi r, what is this r over here? This r over here is actually, now remember, we take the middle of this line segment, okay? Actually, we're on xi, okay? So this is xi, okay? So the r over here, think about it, okay? So what's this r over here? So this r over here corresponds to what? What does it correspond to? Can someone tell me in this picture? This r here corresponds to what?
To y?
To this yi, right? So to this yi over here, to the y coordinate of this point right here, okay? So this yi, this is yi right here, okay? So 2 pi this r over here give you the circumference of this circle, and that circle is by rotating this point about this x-axis. So rotate this point about this x-axis, you're going to get a circle. And the circumference of that circle is this 2 pi yi. So that is the circumference of the circle by rotating this point about this x-axis. So
I have a question.
yes, go ahead.
Do we care about, like, let's say that's a solid. Do we care about the surface area at the two ends, like those circles?
Well, remember we slice it into n slice, right? Each slice over here at this end over here. So you're going to have this also, right? So you're going to have this also, well, not this shape. So either maybe like a cylinder like that, or like a cone like this, or a cone with the top chop off. Okay.
No, I mean, like at the top and the bottom, there's a circle of surface area, right? Because if it's a solid, then
yeah, it is solid.
So you add on that surface area, because that equation only accounts for this.
Okay. Yeah. So that's a very good question. We don't count this top and bottom.
Okay.
So only on the side.
Okay.
Yeah, that's a good question. So the surface area is only on this side. It's not the top and bottom. So excluding the top and bottom. Yeah. So yeah, you have a question. That's a good question. So what happened over here is we only talk about this. Okay, for example, like that. So the surface area will only be, do not include the top and bottom. Okay, no top and bottom. So only on the side. Yeah, we got it. Okay. So that will be this. So this is one band of this. The area will be 2 pi times yi times L. Okay, what is this L over here? So what is this L? Well, the L here is this. So think about this is, remember before? This is a part of the arc, right? Okay. So think about it. Remember when you try to find arc length, the arc length is the integral of the differential of arc length. Okay. So this, think about that is the small increment in the arc. Okay. So that's the differential of arc length right here. So ds is over here. So that's the ds. That's the what we call differential of arc length. Okay. And when you integrate this, so you sum that up, so you get the whole arc, right? Okay. So that is the ds here is the differential arc length right here. Okay. So this L over here is the differential arc length, this ds over here. Okay, so this is for the I stripe right here. Okay, this band right here. Okay. Now we're going to sum this up. Okay, so we sum up n of them. Now we have, I'm going to go to the next page. So we have this, sum this up, okay, put n dash right here. Then we have 2 pi times yi, okay, and then ds. Okay, I go from 1 to n, so we have n of them. Okay. Now remember, now we can let this n go to infinity, so we can slice it even thinner. Okay. So now we're going to let n go to infinity, and then we get this integral, right? So the limit of this Riemann sum is this integral. What integral would that be? So that will be 2 pi. Now we're going to replace the yi here by y, and then ds. So that is equal to the surface area. Okay, let me write it down. What color should I use? So let's use green. So surface area, let's use S to stand for that. So the surface area is the integral of 2 pi y ds, with the y here being the y coordinate. Okay, this is the y. Okay, and then the ds here is the differential apartment. Okay, so that was the formula. Okay, okay. Now let's try to understand this. Okay, so what is this 2 pi? What's this 2 pi? So try to think about this. This is actually the circumference. It's the circumference of the circle. Okay, so this is the x-axis. If you rotate about this x-axis, okay, so you have this, and you take this x. This is x comma y. So you take this point. You rotate this point about this x-axis. So that's the circumference of that circle over there. So that's 2 pi y. Okay, so think about that. And the ds over here, let's see if any of you remember this. Okay, the ds here, you can do it 2 different ways. Okay, remember last time we talked about that? We have 2 different expressions. If I put the dx outside, what should I put inside over here? Inside the square root over here. You can remember? If I put the dy outside, what will be that? You can remember the arc length formula, right? Right here. So the integral of the differential arc length, if you slide it this way, so we have dx. If you slide it this way horizontally, we have dy, right? So if you have dx over here, then inside here will be 1 plus the square of dy dx. And if you put the dy outside over here, then inside here will be 1 plus the square of what? Can someone tell me?
dx over what? Dy?
Dx dy. Yes, very good. Okay. Now remember this one match, right? You see the dx over here, dx, dy here, dy. Okay, the match. Okay. So that will be the formula. Okay. So you can have a surface of revolution by rotating this arc here about this x-axis. You can also have a surface of revolution by rotating about this y-axis. Okay. Okay. So over here, if you have this, then you have also the surface of revolution like this. Now, then the surface area over here. So what will be the surface area over here? Now this time, when you revolve this about this x-axis, then the circumference of this is going to be 2 pi y, right? That's a 2 pi y. The circumference of the circle by rotating this point on the curve about this x-axis. So that's 2 pi y. Now we also take a point over here. Okay, so over here, so we have x comma y. Then the circumference of the circle rotating this point about this y-axis is what? The radius here, it is x. So this will be, instead of 2 pi y, so this will be 2 pi x. Okay, so that will be 2 pi x. And then again, the differential arc length over here. Okay, so that's the formula if you have this arc rotate about this y-axis. Okay, so that's the formula. So it depends you rotating about the x-axis or y-axis. So this is for about the x-axis. This is for when you rotate about this y-axis. Okay. Okay. So this is the differential This is the circumference, and this is the differential of arc length. Okay, now let's look at one example. So we have this curve right here. Okay, x is greater equal to 1 or negative 1, less than or equal to 1. Okay, and well, what kind of curve is this? Well, if you try to find out what kind of curve is this, you can square both sides, right? So we square both sides. So y squared is equal to 4 minus x squared. So x squared plus y squared is equal to 4. So that is a circle. So centered at the origin, right? And with radius to be what?
2.
2. Yes, we got it. Okay. So radius to be 2. I'm going to draw the circle. So radius 2. So that will be the 2 over here. Now this is only part of the circle. Okay. So y equal to positive root. So it's only upper half, right? And then x go from negative 1 to 1. So here it is negative 1. And here is 1. So from here to here. So we only get part of it, right? So only this part right here. And when you rotate this arc over here about this x-axis, so we talk about rotating about this x-axis, we get a surface of revolution. So we got this. So we're talking about this surface area over here. So it's kind of like a ring. So how do we find this surface area? Now to find the surface area, okay, what is surface area? Let's call it S. That's equal to the integral, okay, remember the circumference of the circle, right? And then ds over here. The circumference of that is 2 pi. Well, pick a point on the curve, okay? So this will be x comma y. What's the circumference of the circle by rotating this point about this x-axis? So this is the circumference of this circle.
Y.
2 pi.
2 pi y.
Y? Yeah, you got it. Okay. So to do this, so for the ds over here, that's the differential arc length. Now we need to think about which one to use. For this one over here, y is expressed in terms of x. So it will be easier to find dy dx, right? So from here, so it will be easier to find dy dx. So let's find dy dx. So dy dx is equal to what? Differentiate this, we got 1/2, right? 1/2 what? 4 minus x squared to the what power? Well, this one here, if you rewrite this, that is 4 minus x squared, 4 minus x squared to the 1/2 power, right? So use the power rule, then this one here will be to the negative 1/2 power. Now, and then by the chain rule, we multiply by the derivative of this inner function, which is going to be negative 2x. So simplify this, we got negative x over square root of 4 minus x squared, right? Okay, so we found this dy dx. For the ds over here, now let's do that, okay? So continue over here. So we'll have 2 pi. The y over here, it is what? The y, well, let's see. Okay, let's just leave it for now, okay? So 2 pi y. And then the ds over here will express this. So I have this dy dx over here, right? So I have this 1 plus dy dx over here, and then square, and then I will put the dx also. So this one here makes sense, you slice it this way, right? So it's dx right here. Okay, so dx. And then this would be dy dx. Now, notice that I didn't put the upper and lower limit at this step here because it depends, you put the dx here or you put the dy here. So over here, you don't put any upper and lower limit here. But the next step, once you decide it is dx or dy, you put the upper and lower limit here. What's the lower limit for the x over here? It is what?
Negative 1.
Negative 1, right? And the upper limit is 1. Now you put the upper and lower limit at this step. Now let's do this. So we can take out the 2 pi. Okay, it's a constant multiple. So since this is in terms of x, so we want to express all in terms of x. Okay, so this one over here you want to express in terms of x. Okay, because this is dx right here. Okay, so this will be the y over here. We already know it is the square root of 4 minus x squared. And then we have this square root. 1 plus dy dx is, we already found that out. So when you square that, we got this. Okay? And then dx. X go from -1 to 1. Now, what should I do? What do you think? What should I do? So over here, do you notice that there's 4 minus x squared here and 4 minus x squared here, and both of them are square root, right? And this is multiplication. So you can actually take this, right? You can take this and then multiply, distribute, right? Distribute over here. Okay. So this will be 2 pi. And remember, square root of a times square root of b is square root of a times b, right? Providing that a, b are non-negative, right? Okay. Okay, so this is going to be square root of 4 minus x squared and then plus x squared. Now, when you simplify it, it gets much simpler, right? Make it into 1. So this is going to be 2 pi. Now, this is going to be just square root of 4, right? So this is just 4. Square root of 4 is just 2 dx. And then make it 1 to 1, which is equal to 2 pi times 2x. X go from make it 1 to 1, which is equal to 8 pi. So after all this work, we discovered that there's right here, that the ring that we're looking for right here is actually has this area to be 8 pi. You got it? Okay, I'm going to stop here. Okay, yeah.
Bye.
Bye. Bye, everyone.